Right, we're going to go through the 2022 October-November, paper 3, 31 to be specific. And it should take us 2 hours. Let's go. I'll go buy some items to do some knitting. Knitting is you make a jersey with wool and knitting sticks. Complete Helga's bowl for one shop. 2 pairs of knitting needles at $4.95 a pair. Okay, knitting needles, that's what you use, yeah? To make, that's 2 pairs. And 1 pair costs $4.95. So we did $4.95 times 2. That would be $9.90. $9.90. 2 decimal places because it's money. 6 buttons, 65 cents each. Oh, one button. What have I done? There we go. Right, so we need to do 6 times 0.65. That's $3.90 in total for the buttons. The knitting pattern, and now we need to add those up to get the total. So it's $9.90 plus $3.90 plus $3.60. So you don't put those zeros because they are not important in this case, and that will make us $17.40. Okay, looking at the marks game, that's all correct. You don't have to put the zeros, but it's just better because it's money. Alright, she buys 8 balls of wool from another shop. Each ball costs $3.12. Let's write that down. Alright, she buys 8 balls of wool. Each ball costs $3.12. So that will cost her in total 8 times 3.12. $24.96. She pays with a $50 note. So she now needs to subtract that from 50. Let's have a look. 50 minus my previous answer, so I use the answer button. Change it. That will cost, you'll get $25.04 change. So that's what we write on the line, which is correct if we look at the mark scheme there. Now she starts knitting. She does start with knitting some squares. It's either white, pink, or blue. She's probably going to knit them together then and have like a squarey sweater thing later. The number of squares is in the ratio white, pink to blue, 5:3:2. 30 squares are blue. Let's write this down. There's white squares, and they've got the ratio of 5. There's pink squares, and they've got the ratio of 3. There's blue squares, got the ratio of 2. And then they say 30 squares are blue. So blue there, we put the 30 with the blue. Okay, how did we get from 2 to 30? Well, we need to multiply this ratio by 15, because 2 times 50 is 30. Okay, that means we multiply each ratio by 15, because equivalent ratios, that would be 45. Multiply this by 15, 5 times 15, of course, is, what's that, 75. Okay, is that 150 squares? Yeah, well, so you're going to net 75 white, 45 pink, and 30 blue. We add them together, and bam, that's 150. Okay, remember it says show that, so you have to show as much as possible. Okay, so you get marks. What is this question? Getting the 15. Okay, 5. Showing everything. That will give you full marks. Question D. Helga uses some of the squares to make a rectangular. Oh, she's doing a blanket, not a sweater. The blanket is 6 squares long or 4 squares wide. Calculate the percentage of the 150 squares she uses to make this blanket. Right, so if you got 6 squares long and 4 squares wide, yeah, how many squares are going to fit inside? This is basically area. So 6 times 4, you're going to use 24 squares. Percentage is how we write things out of a total. So it's like having 24 squares out of 150. Kind of when you write an exam and the teacher writes the total out of the total. Only thing is we don't want this out of 150. For percentages we need it out of 100. So you just times that by 100. Okay, so let's put that in. 24 out of 150 times 100, 16% of the squares makes a blanket. And that we got right. Okay. 6 times 4 or 24 gives you 1 mark. Alright, the squares, each square has a side length of 15 centimeters. Okay, so that means to get the length, each square is 15. So to get the length there, we need to do 6 times 15. Okay, what is that? That is 90 centimeters. So that means this blanket here, let's draw it again, will be 90 centimeters long. And same here, to get the width, we need to do 4 times 15, which will give us 60 centimeters. So it will be 60 centimeters wide. Now remember, perimeter means the outside of the shape. So we need to go along the outside, not 90, that's 60, again the 90, again the 60 to get that length, which is the outside of the shape. So we need to add 90 twice, the length twice, and the width twice. You can do 2 times 90 plus 2 times 60, or 90 plus 60 minus 60. Any way that works for you. Okay. Anyway, that will be 180 plus 120, which is 300, isn't it? Okay, check it with your calculator. Yes. Why is mine not correct? Because give your answer in meters. So be sharp. This was all done in centimeters. So yes, the answer would be 300 centimeters. Okay, change that to meters. 10 centimeters meaning 100. So we divide it by 100 to get 3 meters. Yeah, I would have lost the mark there if I was doing this exam for real. Right, question 2. I'm going to try to do this without tracing paper on the screen, so sorry if there's some things that is not so clear. But the first question here, describe fully the single transformation. And before we start describing transformations, let's just remind ourselves of all the different types of transformations there is. Okay, there is the one we call reflection. And that's when we get a mirror image. For example, a reflection of A would be a image flipped over there, like for example, a reflection. In the y-axis, we have a rotation. And this is one that really works best with tracing paper. And that's when a shape turns around. Then we got enlargement. Now, important to remember with enlargement, it's when a shape changes size. It can also get smaller. Okay, so there's a good example here. So there's a C and an A, they're different sizes. So maybe we'll get back to that later. And then, of course, there is, and this is one that people will sometimes write wrong, translation. Okay. Translation is when a shape moves across the page. It stays the same orientation. It just shuffles across the grid. So looking at the first question here, describe the single, okay, so single, just one transformation that maps triangle A onto B. So A going from B. Okay, so what could that possibly be? Well, it's definitely not a translation, because if it's a translation, it would stay in the same orientation, meaning it would have been like this. Okay, it would still have the right angle in the bottom left corner. So that's why it's not a translation. A reflection would flip over, and if it was reflected in this line, we could possibly have that there, but this is not in the core curriculum. Okay, enlargement, again, it could be a negative enlargement, but not in the core curriculum. What we have here is a rotation. So as you can see, I wish I had some tracing paper to show you, but that top corner has rotated to the bottom. Yeah, this corner rotated there, this corner rotated there. It's definitely a rotation because it turned around, rotating. So to get your first mark here, you need to write rotation. That's 1 mark out of 3. Okay, now we can describe the rotation. First, there's the direction it goes in. This, of course, a 90-degree turn, a 180, and then you can go 270. Alright, and we don't have 360. That's a bit silly, just back where you started. Okay, so you could say, yeah, this is 270 as well, 270 degrees. Okay, so looking at this one, if it was 90 degrees, okay, meaning if you draw a line there, 90 degrees will form a 90-degree angle with that line, meaning a 90-degree rotation would end up the shape, okay, over there, like this. That would be 90 degrees, and you'd have to say which direction, anti-clockwise, okay, because if you went clockwise, it would have to be 270. Okay, so that's more than 90 degrees, the rotation we have here. Okay, if you draw a line going there and connect to the other side, you see what's this angle? 180 degrees. So that will be your second mark, 180-degree rotation. And you don't have to say clockwise or anti-clockwise, because it doesn't matter which way you go, you're going to end up in the same place. Okay, that is the second mark. And then the last mark, you need to say where is the center of rotation. And that's where, if you're using tracing paper, you will put your pen in the middle there. You see, this distance is the same as that distance. So in this case, the center of a rotation is the middle, the point 0, 0. Or you can write the origin. See, rotation, 100, oh, they don't say the origin here, but I'm sure you will mark it correct. Rotation, 180.00. So remember, 3 marks, you need to write 3 things. Right, question A number 2, from triangle A to C. Now looking at that, it changes size, and when it changes size, it can only be one, that can only be enlargement. Okay, so that's your first mark, first out of 3, you write enlargement. Now we need to describe how it enlarged. Okay, remember we're going from A to C. So going from this shape to that shape. So it actually hasn't gotten bigger, it's gotten smaller. Okay, if it was the other way around, it would have been easy. Okay, the C is 2 squares high, the A is 4 squares high. C is 1 squared wide, got a base, 2 squares twice as big. So when we go smaller, it's exactly the opposite. It's half in size. So we call that the scale factor. The scale factor is a half. Second mark you got now. Last one, same as the rotation. We need to find the center. To find the center, we connect all the corners. Okay, so you take your pencil and you connect the corners. So the bottom 2 corners are in line. You draw a line going like this. And then the 2 sharp corners, we go like that. And where they cross, that is the center of enlargement. So in this case will be point -1, 1. Remember, along the corridor up the stairs. Don't write it the wrong way around. First the X, then the Y. Looking at the mark scheme, there we go. Go write 0.5 instead of a half, that's fine. And -1, 1. Question B, reflect triangle A and the line Y equals 0. So what does the line Y equals 0 look like? Let's think about that. I'm going to use a different color here. So let me tell you right. The line, if we were to draw a line here, that will be the line Y equals 6. A line over here, that will be the line Y equals 4, because it goes for 4 on the Y-axis. This line here, of course, Y equals 2. So the line Y equals 0, that is the X-axis. So they might as well draw a line in the X-axis. The line Y equals 0 is the X-axis. So that's what we need to do the reflection. Now, you've got a mirror, it's awesome. You can even do this with tracing paper. Doing it without is also not too difficult. Alright, if you take a corner like this right angle corner, it is 1 square away from the line of reflection, so we go 1 square on the other side, so that point will now be over there. Same with this corner here, 1 square, 1 square. And then the top corner there, the smallest angle, this one is 1, 2, 3, 4, 5 squares away from the line, the mirror line. So we got 1, 2, 3, 4, 5 on the other side. It will be over there. So important, with the reflection, your new shape should be exactly the same size. Okay, just a mirror image, of course, because it's a reflection flipped over, and that's what it looks like. Okay, use a pencil. So if you want to rub anything out, you can. All right. So you look at the mark scheme, it will give you the coordinates. Okay. If you reflect it in the wrong line, you might get 1 mark. 2 marks have to be reflected in the correct line. Question B2. Translate. This is when the shape just moves across the page by the vector -7, 1. Now remember how we write vectors. The top number tells you left or right, and of course if it's negative we go to the left, so we need to go 7 squares to the left. Of course it's -7. The bottom number tells you up or down. Of course up is positive, so if we've got a 1 there, we need to go 1 square up. So we need to move shape A 7 squares to the right and 1 square up. So let's do that. Okay, having tracing paper makes it easier, but we can do without. Okay, we're going to do the right angle, 7 squares, 1, 2, 3, 4, 5, 6, 7, and then 1 square up. So that's where it needs to be now. Okay, we can do the same with every other corner, yeah? 1, 2, 3, 4, 5, 6, 7, and then 1 up. Or we can just draw the shape exactly like it is. So we know that the last corner is 4 squares above the right angle, so the 4 squares above needs to go there. Okay, and there we go. That's where the new shape goes. Again, the mark scheme there will show us the coordinates, which is what we have. And we've done it. Question 3. Takes Miguel 40 minutes drive to work. He leaves at 7:45. What time does he arrive at work? Okay. A good method to use here is what they call the leapfrog method. We write 7:45 down. First thing we're going to do, we're going to jump to 8 o'clock. That would be a 15-minute jump. Now remember, he was driving for 40 minutes. We've already done 15 minutes. So what's left to do is 25 minutes. We jump another 25 minutes. That gives us to 8:25. That's when he arrives to work. Okay, next thing I talk about speed. So do you remember this formula for speed? And it's not hard to remember because that actually is the formula, you see? Kilometers divided by hours. So draw your triangle. Speed always goes here. This is the speed, 57. Okay, kilometers is the first thing above that line. So it means distance goes at the top, because kilometers is distance. All right, so that's distance. And then hours, of course, is time. And that's below the line. So that's the formula right there in the units. Speed equals distance divided by time. Okay. So, show that he drives 38 kilometers. So what we need to do is 38 kilometers, of course, is the distance. That's what we want. So, oh, that disappeared. That was weird. Okay. So, to get the distance, we need to do speed times time. Speed we have there, 57. What's the time again? They told us there at the beginning, 40 minutes. Okay, are we going to do 57 times 40? No, we're not. Be careful, because remember, speed is kilometers per hour. And this is minutes. Okay, so what is 40 minutes? Is 40 minutes 0.4 hours? No, it's not. Okay, because we count things differently, we can't just make it a decimal like that. Remember, this is 40 minutes. How much is an hour? 60. 40 out of 60. So if you want to change that to a decimal, you need to divide it by 60. That means 40 minutes equals 0.6 recurring of an hour. Okay, so speed times time, time in hours, 0.6 recurring, 2/3 of an hour. That is what 40 minutes is. Okay, so we got that on our calculator, 0.6 recurring, just times it by 5 is 57, and we get 38 kilometers. And we know we got it right. Okay, look carefully at the mark scheme here. And we got 825 correct. Okay, 57 times 40 over 60. Okay, so I will get my 1 mark. I showed the 40 over 60 there. And then I times that. That's how you get your 2 marks. Right, question B. This is all about writing an expression. You didn't remember what is an expression. Okay, in algebra, there's 2 things we get. Okay, an expression is something with a letter in it. Something as basic as 2x plus 1. That's an expression. Opposed to an equation which will have an equal in it. Okay, so this is an expression. And this is an equation. Okay, now forget, this has got nothing to do with actually the questions. What we need to do is we need to write an expression, something without an equal, something algebraic without an equal, with a W and a P in it. So we got white sheets of paper, and there's 56 of them. So you write 56 times W, because there's a job, and 21 sheets of pink paper, that will be 21p, and they want the total, so you add them up, and that's all you need. That's an expression. Okay, final answer, 56w plus 21p, 1 mark for each. Question C, began as a box of pens in the form of a cuboid. That's a cuboid, something like this. Alright, and it's got measurements of 20, 12, and 7, not drawn to scale, of course. Calculate the surface area of the box. Okay, this is not volume. Many people will go 20 centimeters times 12 centimeters times 7 centimeters. Okay, multiplying centimeters by centimeters by centimeters gives us centimeters cubed, which is volume. Okay, so don't do that. Don't multiply everything together. That's wrong. We want centimeter squared because it's surface area. So that means we can only multiply 2 of those numbers together at a time. So if we're going to do 20 centimeters times 12 centimeters, that will give us 240 centimeters squared. By doing so, we have actually worked out 20 times 12, the area of the base. Okay. Right, now the base of the cuboid, of course, is the same as the top of the cuboid, so we need to do that again, or we can times it by 2. Okay, timesing it by 2 this time, we're not timesing it by 2 centimeters, we're just doubling it, so that's 480 centimeter square. So it doesn't change the fact that we're working in squares. Okay, this gets us the area of the top and the bottom. Of the shape. Okay, let's swap to another color. Now we're going to take 2 other numbers here. I'm going to do 12 and the 7. Multiply the 12 and the 7 together. Again, that will give us centimeters squared. which of course is 84 centimeters squared. 12 and 7 will give us the area of the front face. We're going to double it, so we have the area of the back. So we do 2 times 84, what's that? 168. Okay, this will be the front and the back. Right, let's use beautiful green now. So there's two numbers we haven't multiplied together yet. We haven't multiplied the 20 and the 7 together. If we do that, we will have the area of the side, which will be the right hand side, anyway you look at it. So that was the 20 times 7 is 140. Of course, we're going to multiply that by 2 because that will give us the area of the left side. So 2 times 140, 280. This now is the area of the sides, the left and the right side. Okay. What we need to do, the final step, is take the top and the bottom plus the front and the back plus the two sides. We add them together. And we have the final answer, 928. Let's have a look at the mark scheme. Yep, that's right. Okay, now there is lots of different formulas to do it, to write it down. The mark scheme always shows the shortest possible way. It doesn't mean you have to write it like that. Okay, you can break it down like I have to get the final correct answer. Question 3D, Miguel is making some phone calls, receiving some phone calls, and this shows how long the phone calls were. So this one, for example, that will be the first one, 7 minutes. Then in one of 15, then of 6, then 28. He's talking a lot on the phone, isn't he? Okay. So we need to put that into a tally chart. Remember, tallies is like being in prison. You count the days. 1 day, 2 day, 3 day, 4 days. When you get to 5, you draw a line. Then you go 6, 7. Okay. So, putting in the tally chart is best practice to go one by one. You're much less likely to make any mistakes. So, 15 is between 11 to 15. 6 is between 6 and 10. 28 over there, etc. Frequency then is just how many ticks you have. So for the first group there will be 2 phone calls were between 0 and 5 minutes long, then 4 phone calls between 6 to 10, etc. And there we go. It's always a good practice to add everything up, yeah? How many phone calls are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 in one row, so there's 20 phone calls. And when we add up the frequency, that should equal to 20 as well. 2 plus 1 is 3, plus 6 is 9, plus 5 is 14, plus 4 is 18, plus 2 is 20. Yes, we got it right. Or just check the mark scheme. 2, 4, 5, 6, 2, 1. 2, 4, 5, yes, we got it right. Right, draw a bar chart, complete the scale on the frequency axis. It means you need to write the numbers on the left hand side. The highest number we have here is 6, so we can go up on ones. What's important here is that the gap between the numbers remains the same. Okay, and then we draw the bars of our bar chart. So you take a ruler and a pencil and we start drawing those bars. Right, what's important here is, of course, that the bars are the correct height, but also that they are the correct width. They all should be the same width. Okay, then it says use the bar chart to write down the modal group. Everybody else says, what's modal? Modal means most. Modal is what we say when we have the groups. So which group has the most phone calls in? And that, of course, will be this one. 16. Most phone calls will be between 16 and 20 minutes long. And that's finished for that one. Looking at the mark scheme, yeah, we got it right. Question 4. A multiple of 3 between 70 and 80. And the multiples of 3 is, of course, 3, 6, 9, 12. So we have to go all the way between 70 and 80. Okay, speed things up, use a calculator. We know that 3 times 60 is... what I was trying to say is 3 times 20 is 60, so it will be slightly more than 20. Let's say 3 times 22. No, 3 times 24. There we go. 72 is a multiple of 3 because it's in the 3 times table. Okay, of course a little trick as well. If you add the 7 and 2 together, you get 9. 9 can be divided by 3, so 72 can be divided by 3, so 72 is in the 3 times table. Of course there's other numbers, 75, 78, there is more. Yeah, check all of them, add them together, you get a multiple of 3. 7 plus 5 is 12, which is in the 3 times table. 7 plus 8 is 15, which is in the 3 times table. Factors, on the other hand, that is stuff that divides into. Okay, so the factors of 63 will be 1 and 63, 3 and 21, because 3 times 21, goodness, is 63, of course, right? So, etc. So we need one between 5 and 10. So let's think, what could that possibly be? Can't be 6, because 60 divided by 6 is 10. Okay, what about 7? Does 7 go into 63? 63 divided by 7. Yes, because 6 times 9 is 63. So the number, the factor of 63 between 5 and 10 is 7. Cube numbers is the numbers cubed. 1 cubed is 1 times 1 times 1 is 1. Then 2 cubed is 2 times 2 times 2 is 8. These guys go up quite quickly, because 3 cubed, 3 times 3 is 9, times 3 is 27. Then we got 4 cubed, 4 times 4 is 16, 16 times 4 is 64. Check out on your calculator, you put 4, and there's the cube button, 64. So that's the correct answer there. Okay, nothing else. So we got 7 or 9 for the previous one, of course, and 64. Reciprocal means the opposite, the inverse. Okay, so we got 7, which we can write as 7 over 1, because 7 over 1 is as a fraction. Reciprocal just means the inverse, so you swap it around. Okay, or more with the mathematical definition, when you multiply a number by its reciprocal, you get the answer 1. So if you do 7 times 1 over 7, we get the answer 1. That's the mathematical definition. So anyway, what we're looking for here is 1 over 7. Okay, or if you want to put the decimal value, you can. It's unnecessary. Working out 2 7s of 48 simply means you need to do 2 7s times 84. You got your calculator, so use it. So 2 7s times 84, 24. Okay, quick mark there. Now here we go. All of this is this can be done on the calculator. You just need to know how to put things in. Cube root is, of course, shift, and the cube button, you put in 3375. Bam, you got 15. 12 to the power of 0. If you can't remember what that is, but you should know, anything to the power of 0, of course, is always 1. Check it on your calculator if you can't remember quite. Then we came to Rana, hiring a car. And she pays $461.50. So we need to work backwards. Let's start with what she paid. Okay. So of course, she paid the delivery cost. So if we take away the delivery cost, let's do that first. So 461.5 minus 17.5. That is $444 she paid just for the rental, which was $74 per day. So we can add up 74 until we get to 444, or we can divide it into it, and that will give us the amount of days. So we divide it by 74. 6 days it is. Okay, because 6 times 74, 444 plus 1750. Where are we? There we go. 6 days. Not from wrong working. So it means if you don't have the right working out here, don't get your marks. Okay. Here you don't have to write it like they do in the mark scheme. This is just the shortest possible way. But what they get at is you should minus 17.5 and divide 74. Question E, we have some trains leaving a station. We got train A and train B. There are different ways to do this. Many different ways. You can use common prime factors, product of prime factors, or we can just simply do the multiples, right? So if you got a train leaving every 25 minutes, you got one leaving after 25 minutes, then after 50, then after 75, then after 100, then after 125, then after 150, then after 175, okay, then after 200 minutes. Let's see what happens with a 45-minute one. You got one leaving only 45 minutes, then add another 45, that's 90 minutes, then one leaving after 135 minutes, add 45 to that, you now have 180 minutes, and then add another 45, that's 225 minutes. Okay, of course you can use your calculator to do this. So, okay, but we're already close. Yeah, because if we just add another 25 minutes to this one, we've got it. After 225 minutes, we'll have the trains leaving at the same time again. So what we need to do here is from 8 o'clock to get the time, we need to jump 225 minutes. Let's see how that goes. So first we're going to jump, I'm going to jump 60 minutes, so I get to 9 o'clock. So that's 60 minutes. Jump another 60 minutes. That will get up to 10 o'clock, so we're now on 120. Let's jump another 60 minutes. That's now 180 minutes. Let me just write this a bit better. How much do we still have to go? Let's see, 225 minus 180. That is 45 minutes. So we need to jump another 45 minutes. That's 11:45. Yep, that was jumping 225. So the time, they both leave at the same time again, 11:45. Looking at the mark scheme there, like I said, there's different ways to do that. I've used the method down here, listing the multiples of both, and then working out the time. Or you can try the other method if you want. Question 5. The table shows the number of items sold to each 60 customers in a shop. Okay, what does this tell us? There were 3 people who came in and bought nothing. Then there are 6 people who came in and bought one thing, etc. And these 4 people here, they bought the most stuff. Each one of them bought 7 things. Items, they call them. Okay. So what is the range? So be careful here. What is the range? What is the most things that people bought in the shop? And that would be 7 most. Yeah, those 4 people that bought 7 stuff. And what's the least amount of stuff people bought? Nothing. So people bought between 7 and 0 stuff. That's a range of 7. Okay, we're not using these numbers to work out the range. That's the big misconception. Now the mean is always the mean one to work out. Okay, we need to add up everything, which means we need to find everything that was bought in the shop. So we just start with this first 3 people, right? They bought nothing, so there's nothing on our list being bought. But then there were 6 people who bought 1 item. That's a total of 6 things. 12 people buying 2 things. That's a total of 24 things, etc. And the last 4 people, they bought a total of 28 things. Okay, so adding that all up, there was a total of 206 objects bought. Okay, so 206 objects was bought by how many people? 60 customers. It tells us there, but also if we add up the frequency, we should get that 60. So if 60 people buys 206 things, we need to do 206 divided by 60. That means on average, each person buys 3.43 recurring things. So a little bit between 3 and 4 things is what people buy. Put the recurring. Okay, so looking at the mark scheme here, 3.43 or 3 or 13 or 30 as a fraction. Okay, show this working out where you multiply the stuff together and then where you divide it to get full marks. Alright, probability, we always write it as a fraction, a decimal percentage. I think here fraction would be best. Okay, there were 60 people who bought stuff. How many of them bought more than 4 items? So we go back up here. Buy more than 4 items will be these people. That is 17. So that means 17 out of 60 people. That's all you really need to write. If you want to change it to a fraction, to a decimal or a percentage, I guess you can, but that would be unnecessary. Okay, best thing, 17 over 60. Show your working out there, which I haven't. Question 5b. The length of a bicycle is 96 centimeters. Correct to the nearest centimeter. Complete the statement about the value L. The moment you see this, correct to the nearest, you know it's been rounded. This is what we call bounds. Okay? Correct to the nearest centimeter means correct to the nearest 1 centimeter. So we need to write what the possible values is before we rounded it. Okay? So that means we need to write 96 point something. To help us, one method here is to take that 1 centimeter divided by 2, which gives us 0.5. This is what we have to add and subtract to get the upper and the lower bounds. So to get the lower bound, we subtract 0.5, which is 95.5. That will be the lower bound. The smallest number up to 1 decimal place to the nearest centimeter, we'll go round up to get 96. To get the upper bound, we do the same. We do 96, but we add it this time. That gives us 96.5. And that's what we write as the upper bound. Now, yes, I know. If you round 96.5 around to 97, that is why we have the less than sign and not equal like the previous one. So it means less than 96.5, which does not include 96.5. That is why we do not write 96.49 recurring, but 96.5. If you look at the mark scheme, that is what it says over there. Okay, and that's what they're looking for. Question 5b part 2 talks about a bicycle wheel. Let's draw the bicycle wheel. Almost round. Okay, it's got a diameter of 46 centimeter. Okay, now remember, when a wheel rolls over the ground, okay, once it rolls once around like this, that distance will be the circumference of the circle. That will be 1 rotation of the wheel, or 1 revolution of the wheel. So the circumference of the circle will also be the length of that distance. So first thing we need to do is work out the circumference of the circle, and that's pi times diameter. So we do pi times 46. So let's do that. 46 times pi, or pi times 46. Okay, that gives us 144. Now don't round your answer yet. So write loads of digits, like these, like 5 or more. Or you can just leave it as 46 pi. That's another good method to do this. Okay, so that means one roll of the wheel is about 144.51 centimeters. Okay. Now we have to keep rolling the wheel until we get 104 kilometers. The next step would be to change 1.4 kilometers to centimeters. Not meters, centimeters. Right, so we multiply it by 1,000, because kilo means 1,000. That will give us 1,400 meters. Then, of course, we still need to multiply that by 100 to make it centimeters. So that will be 4 with 4 zeros, 140,000 centimeters. That's how many centimeters is in a kilometer. So to see how many times the wheel rolls, we need to divide 140,000 centimeters by 144.51, etc. centimeters. Okay, and 140,000 divided by 144.51. Okay, that gives us 968.79. Okay, so what would be the final answer here? Let's think. Are we just going to round into 3 significant figures? No, they said complete revolutions. Okay, meaning we can't round it to 969 because it didn't turn around 969. It did 0.79 of that last revolution. So only complete revolutions is 968. So in this case, we need to round it down to get full marks. 968, there it is. Okay, getting marks for various parts of that question to show as much working out as possible. Question 6a, this of course being a cylinder. Question B, find the value of x. Alright, first what we have here is, let's start with the angle we have. We have angles on a straight line. The first step would be 180 minus 104 being 76. Write it in there. Then if we start to look at what other information we have. We have this BE equals CE. We have there's lines, which means this is an isosceles triangle, meaning the two base angles is the same. So this is 76 over there. So now easy. Angles in a triangle being 180. We just need to subtract the two angles we have, 66 and 66 from that, and then we'll have the answer. $28. And there we go. Question C, regular polygon means all the angles inside the polygon. Polygon means a 2D shape with many sides, in this case 15. So for this you need to remember the formula. The formula being the number of sides minus 2 times 180. And this formula will give you the sum of the interior angles of any polygon. If you forgot why that is let's run through the basics. A triangle, the angles interior of a triangle adds up to 180, as you know. If you take a quadrilateral, any four-sided shape, okay, having a triangle got 3 sides, quadrilateral's got 4 sides. Inside there would fit 2 triangles, and each triangle being 180, that would be 360. If you take a pentagon, inside there would fit 3 triangles, 3 times 180 being 540. That's for a 5-sided shape. So if we take the number of sides, subtract 2 from it, and times it by 180, we will get the sum of the angles inside. So meaning 5 minus 2 is 3. 3 times 180 is 540. And it continues like that. So in this case, if we take the 15 sides, we subtract 2 and we times it by 180, we get a big number. 15 minus 2 times 180, 2,340 degrees. That is what all the angles inside the 15-sided shape will add up to. We want the size of one of those angles, and there being 15 of them, we just need to divide this by 15. So we take that number, divide it by 15, and there we go. It would add up to, it would be 156 degrees. Okay, and that's what we have. And there's the formula you need to use. Question D, the line BC, what do we call it? It's not a radius, it's not a diameter. A line inside a circle, that's not the radius or the diameter, is called a chord. Okay, not a chord. But if it helps you remember, call it a chord. Because they want to ask you to write it down and not say it. So remember, chord, but it's called a chord. Draw a tangent. So they check if you know what a tangent means. Tangent is a line that touches the outside of the circumference. There we go, that's a tangent. Okay. Then it gives us the area of the circle. So area of a circle, immediately think of the formula. A equals pi r squared. Remember that? Okay. So A equals pi r squared. Area of a circle. What do we have in this formula? Well, we have the area, so let's put that where the A is. We got pi on our calculator, we just need the radius. So what's the radius here? Well, here we got a line going through the center. That will be the diameter. Okay. And they want us to calculate AB, which is the diameter. But remember, the diameter is nothing more than just the radius plus the radius. So half of this will be the radius. So let's work out the radius using, what's going to happen here? This formula. So we want to work out what's r. We need to move the pi to the other side. So we are going to do the opposite of pi times r squared, which is divide. And then we need to move the square to the other side, the opposite of square being square root. So we need to do 245.5 divided by the square root of that. That will give us the radius. So let's do that. Which gives us 8.399,704. Now remember, that would only be half the diameter. So we're talking about this distance. We just work out. So to get the whole distance, we just double it, and then we have the diameter. So on our calculator, still have it there, times it by 2. There we go, 17. Let's write that down thoroughly. So what we did was, we did 2 times 8.8399, and that gives us 17.679. Good answer. If you got it rounded to 3 significant figures, which is 17.7, or write the whole answer. There we go, 17.7, or the unrounded answer. Got it. Next one, find the value of y. So let's look at y. There it is. What is this? Inside a triangle. Good. What do we know about this triangle? Well, we now got one angle here. What about this angle here? How big is it? How big do you think it is? You think it's 90 degrees? Even though it says not to scale, it is 90 degrees. Because you need to remember this circle theorem. An angle in a semicircle is always 90 degrees. Meaning, if you have the diameter of a circle, then the angle formed from that would always be 90. Okay? Angle in a semicircle. Circle theorem. Go study it. Okay, so that means yes, to find y, we simply have to do the angles in a triangle adds up to 180. Subtract from that the two angles we have, which is 90 and 38. And then we'll have what we're looking for. $52 degrees. Okay. So you get 1 mark for identifying that 90-degree angle, alright, or showing you're working out, and then 52. Question 7a, simplifying, collecting like terms. Here we got a 5g and a negative 7g. That negative goes with the 7g. Sign always goes with the number. The sign is always in front of the number it goes with. So 5g minus 7g, 5 minus 7 being negative 2g. And then we got minus 3h, the minus there going with the 3h, and a positive 6h. A minus 3 plus 6, of course, gives us a positive 3h. So minus 2g plus 3h. Can't add those two together. Can't add grapes and what starts with an H. Hemoglobin, whatever. Can't add them together. They're different things. Apples and pears. Okay, next one is substitution. So if we want to know what g is, we need to take g equals 4, and instead of the k, we need to put the minus 5. We're multiplying here, so you write times minus 5, we'll put it in brackets. Plus 7, and instead of the m, we put a 6. Okay, don't waste your time here, just go bam, bam. Where's the minus 5 plus 7 bracket 6 there? 22 it is. There we go, mark scheme correct. Factorize, now remember that's the opposite of expanding brackets. We need to make brackets. Okay, one way of doing this is breaking down the numbers into their factors. 14 is 2 times 7 is 14. And then we got x cubed, which means x times x times x. So each dot here, remember, that means multiply. And the other term, 49, of course, is 7 times 7, and there's 1x. Now what we do then is recognize the common factors they have. Both of these have a 7. So we write 7 down. Both of them has at least 1x. So we write the x. And then we open our bracket and we put everything that's left. 2xx is 2x squared plus, and there's just a 7 left. Okay. So meaning when we expand this bracket, 7x times 2x squared, 7 times 2 is 14, x times x is x cubed, 7 times 7 is 49, x times 1 is x. So that's how we know we got it right. 7x over 2x squared plus 7. Okay, final answer. Be careful for partial factorizations. If you only factorize out the 7 or 1x, you only get 1 mark. You need to fully or completely, like they say here, factorize it. Everything that can be factorized. Solve. Question D, we need to find out what is t. There are two ways to do this. We can expand the brackets first, or we can divide the 8 first, whichever you fancy. I'm going to divide the 8 first. So that's 8 times the bracket, so we need to divide 8 from both sides, or divide the 8 from the 108. Go 108 divided by 8 gives us a fraction, so that means 3t minus 9 equals 13 and a half. Next thing to do is add 9 to both sides, or add the 9 on the opposite side. Do it the lazy way. So 3t is 22.5. And the last step would be to divide 3 from both sides, or divide the 3 on the opposite side. So we divide that by 3. And we get the answer, 7.5. Write it as a fraction or a decimal, doesn't matter, 7.5, 7.5. Okay, you'll see here the mark scheme, they show the 2 steps. You can expand the brackets, like I said, or we can divide the 8, is what I did. Question E is, remember, when we divide with indices, we subtract the index, the little thing at the top. Meaning, because we are dividing and the base numbers here is 999, that means 24 minus W equals 5. Do you understand what I'm saying here? If this was 2 to the power of 5 divided by 2 cubed, the answer would be 2 squared, because 5 minus 3 is 2. Okay, same thing here, just a bit backwards. So, how do we solve this? 24 minus what is 5? Let's swap them around. Let's put the 5 over there. So the 5 becomes minus, that will be positive, that's 19. 24 minus 19 is 5, so the answer is 19. There we go, 1 mark. Next question. Again, this is just solving it. So if we got 4x squared equals 256, divide both sides by 4, or divide the 4 on the other side. So you got 256 divided by 4. No, I typed that wrong, didn't I? Yeah, 256 divided by 4, 64. And then of course the opposite of square root. So to find x, we're going to square root 64. Square root of 64, if you remember, is 8. Okay, because 8 times 8 is 64. Now, there is another answer here. Okay, we know the square root of 64 is 8, because 8 times 8 is 64. So we can say the square root of 64 is 8. Okay, but if I were to take a negative 8 times a negative 8, I also get the answer 64. So we could say the square root of 64 is negative 8. That's why when we do this right, we like to put a plus and a minus. Plus minus 8. Looking at the mark scheme, well, they're not bothered about that. If you just write 8, you get your marks. Right, there's Ranjit. Let's write Ranjit down. Ranjit is R. He's got X years. Susie, let's write Susie, is 3 times Ranjit's age. So 3 times X is, of course, 3X. Juan, it's very international. Juan's age is 4 years more than Susie. So Susie's age is 3X. Then Juan's age will be 3X plus another 4 years. The total of their ages is 46 years. So, meaning if we add all their ages together, we should get 46. Okay, they told us to write down an equation, and that's what we've done. It's got an equal sign. Okay, so that's an equation. So we've done this first thing. I'm sure we're getting some marks for that. Now we just need to solve it. We do the solve part now. Okay, so add the x's together. 1x plus 3x plus 3x, that will be 7x. Then subtract 4 from both sides, subtract the 4 from the other side, you get 7x equals 42. And the last thing to do is divide both sides by 7, or 42 by 7. So x must be 6. Okay, so look carefully here. Showing all the steps is important to get your marks. Writing the equation, simplifying, doing the rec, moving around, and then getting the right answer. Question 8a, vectors. Okay, work out for a. If a is minus 3 over 5. 4a would be 4 in front, meaning we need to multiply the top by 4, which is minus 12. Multiply the bottom by 4, which is 20. We are extending the vector 4 times. So we do the same for the next one. We do 2 vector A, then minus vector B. Alright, let's just make sure we do this right. So first we multiply the 2. We do 2 times minus 3, which of course is minus 6. And then we subtract the 7. 2 times minus 6. 2 times minus 3 minus 6 minus 7. That will give us minus 13. Okay. Don't be shy to check this with your calculator if you're getting confused. Okay. Minus 13. Next one as well. We do 2 times 5. And then we need to minus a negative 4. Okay, so 2 minuses makes a plus. 2 times 5 is 10. Minus 4 is plus 4. That will give us 14. Don't be shy to check this with your calculator. Minus 4, 14. Okay, and then you check the mark scheme if you're in my position. And you say, yes, all is good. Right, question B, coordinates of P. Remember, we always go along the corridor, up the stairs. So that will be 3, 1. Plot the point minus 4, 2. Along the corridor to minus 4. Up the stairs to 2. So let's put it there. And to name it. Okay, to show that you're thorough and you know what you're doing. That is point Q. Then they give us the vector. We've discussed this before, I think. Haven't we? Maybe it was another paper another day. But with vectors, the top number tells you how to go left or right. Of course, to the right is positive, to the left is negative. The bottom number tells you up or down. Of course, up is positive, down is negative. So minus 2 means we need to go 2 to the left, and 1 means we need to go 1 up. So PR, starting at P, we're going to go 2 to the left, 1, 2, and 1 up. That will be the line PR. So the point R would be there. And again, be professional. Make a little R there. Okay, let's see if that's right. R plotted at 1, 2. That's where we got it. Last one, draw the line y equals 3. Can I use my pencil? Y equals 3. There's y. There's 3. Say a line would go through 3 on the y-axis, across like that. Because it doesn't matter where on that line you are, you're always in line with 3 on the y-axis. The x-axis changed, but it's not relevant here. So that's the line y equals 3. Question C. Write the equation in the form y equals mx plus c. First of all, m is the gradient. Now remember, m is the change in y over the change in x. So let's see. Let's draw a triangle. On here, if you draw a triangle, don't start there, because you can only make like a part of a square. You don't know how much that is. Okay? If you're going to draw a triangle, start somewhere like there, where you can use whole squares. Okay, now how big this triangle make doesn't really matter. We can go 1 to the side and 2 up, so 2 over 1. So the change in y up and down is 2. The change in x is 1. That gives us a gradient of 2. If you made this triangle bigger, let's say you went 2 squares, then you would have to go 4 up. That will be 4 over 2. 4 divided by 2 is 2. You'll get the same answer. So don't worry about the size of the triangle. Just make sure it's right. So that means already in our equation, we got y equals the gradient 2x. Then we just need to find the c. And that's easy. That's the y intercept, where it crosses the y-axis. And in this case, it's minus 3. So that's our answer. Y equals 2x minus 3. There it is. Okay. Write down the equation of a line. So it could be any line that is parallel. Any line that is parallel will have this same gradient. So I'll draw a line there. Okay. It would have still the same gradient, 2 over 1, which is 1. So all you need to do is write the first part the same and put anything afterwards, anything or nothing. Okay, the line I drew there would be y equals 2x. That's it. But if you put plus a million back there, doesn't matter. That line would still be parallel. Okay, as shown here. Y equals 2x plus k. K can be anything. Okay, or it doesn't even have to be there. So just y equals 2x. Okay. Question 9. Sammy buys a car. Looks like a decent family little sedan. Maybe a Dacia or something. She pays a deposit and then 36 equal monthly installments. Okay, so let's just write it down as it is. First she pays 2,250. Then she pays 437.5 for 36 months, which is 3 years. 2250 plus 437.5 times 36. That's 18,000. How we showed how to do it? Yes, we wrote down the calculation. There we go. Okay. Write down as much as possible. Right. Percentage loss. First of all, let's see actually how much money did she lose. She bought it for 18,000. She sells it for 13,680. So we subtract that 13,680. She's lost $4,320. Write this as a percentage, just like when you write an exam, your teacher writes your mark out of the total, and this is always the original total. That will give us a fractional amount or decimal value, 0.24. To change that to a percentage, just times it by 100. 24%, that's what she lost. Okay, you don't have to put a minus there. It's 24% loss. And they understand that. So you show the subtraction divided by 18,000. And then you go. There is other methods they show there. But this is the most straightforward for me. Anyway. Right, compound interest. So this formula, it's basically, remember this formula, the amount that you have at the end. Okay, is the principal, the original amount, in this case 12,750, and it's 1 plus the rate, 1.8%, divided by 100 to the power of the time, and this would be 6 years. So we do 12,750, 1 plus 1.8 over 100 to the power of 6. $40,190.47, etc. Okay. Do they say how we need to round this? No, they don't. So I'm going to write it to 2 decimal places since it's money. But they're happy if you round it to 3 significant figures or what I've done. Okay. Just don't round it to less than 3 significant figures. Don't write 14,000. Okay. But 14,200 is fine. Once you look at that, we're at the end of the paper. Well done, good luck, study hard, be a champion. See you again soon.